Welcome. We have a question here on chemistry. The question reads, what time is required to deposit 6.3 gram of copper from copper 2 tetraoxosulfate 6 solution by passing current of 2.6 ampere? So we are asked to calculate the time it will take to deposit this particular mass of copper from a solution of this copper 2 tetraoxosulfate 6. By looking at this question, you observe that this is electrolysis, and to that effect, let's just solve it quickly. Solution. Now, before we solve this, we need to understand that this is copper 2, and you know that copper is this way. We have our copper as Cu, then because it's copper 2, we must balance this charge with 2 electrons. Sorry. You know, according to the subatomic particles of matter, according to John Dalton, we are meant to know that electron is negatively charged. So because of that, we have it to be this way. This will give us normal copper. This will give us normal copper. Now, what it means is that 1 mole of every copper requires 2 electrons. That is automatically what it means. Then remember that they gave us that 1 Faraday is equals to 96,500 coulombs. Now, well, what it means is that this particular 1 mole will give us 2 Faraday. That is what it means. Now, on this ground, we are having the mass of copper as well, 64. We have 64 gram will give us how many? It's going to give us 2 multiplied by 96,500. Now let's use calculator and punch it on calculator to get our answer. We have 2 multiplied by 96,500. It will give us 193,000. This is the same as equals to 193,000. Now, if 64 will deposit 193,000, how many will 6.3 deposit? We have 6.3 gram will deposit S columns. Now, by cross multiplication, we're going to cross multiply this way. Then we have it that this particular number that we have here, this is the number that is being represented. Now we have 6.3 gram multiplied by this particular number, 193, then everything over 64. Now let's check. Times by 6.3, then divide by 64. It will give us 1898.4375 columns. This is what it will require to deposit this 3 gram. But it's not what they're asking us. They didn't ask us the quantity of electricity, but they asked us the time. You know that according to the Faraday law of electricity, we have it that the quantity of electricity is equals to current times time. Since we have it, this is our quantity of electricity. By substitution, we're having our time. We have it that we divide both sides by the coefficient because we are looking for the time. We are dividing both sides by I, which is the current. So we have it that T is equal to quantity of electricity over the current. Then for us to divide it by that, we are having it that our time is equal to this particular number, 18,998.4375 divided by they gave us the ampere as 2.6. Let's divide by 2.6. Divide by 2.6. It gave us This is equal to, please let me write the answer here. It gave us this as the answer, 7,000 or 7,307 point, okay, yes, 0.09 seconds. This is what it will take, 7,307.09 seconds. Thank you and bye.